All right. Hello, GPC. Hello. Welcome to our session on optimization. I'll be your incredible teacher and host, Jonah. Uh, our subtitle for today is faster is always better, right? The answer is not always. Uh, so what are we going to be talking about? We're going to be talking about optimizing. So what is it? When to start optimizing your code, how to access the main tools of optimizing, such as your profiler, uh, and then just a handful of techniques that can make your code run faster and look cleaner. And then there'll be an example at the end that I put together. Well, there's a couple of examples, but one big one. I won't be able, big optimization things, but a lot of these will be good coding habits to have, and a bunch of things that you might not even think of that can cause performance problems down the line. So what is optimizing? As I so eloquently put, it is make code run faster. Uh, Mostly. Optimization generally just means reducing the operation time or the amount of garbage you're creating in your code, which will improve performance, speed, and overall efficiencies of what you're running. So when do you start optimizing? That's a very important question. It's different for a lot of projects, but the overall is do not start optimizing prematurely. If you start right from the beginning with your optimization, you're going to spend too much time thinking about, how you're writing your code and how you can make it as fast as possible without actually thinking about things like possibly maintainability, modifying it later, or you might make it harder to read because sometimes the most optimized solutions possible can actually be more difficult to read for somebody else picking up your code. So you actually want to go with writing functional code first. So generally, you want your thing to function, possibly even function in conjunction with other systems before you start the optimizing of it. If it works, it works. Then you make it faster. That way, you have functional code, and then you know how things interact together before you try to optimize. Another thing is avoid over optimizing your code, because code that is too optimized might be very hyper specifically written in a way that only you understand, and then when you have to pass that off to somebody else, or you put the code down for a couple of months and then pick it back up later, you might not have any idea why it works the way it does because you've put too much effort into doing weird things that are just slightly faster. So yeah, it's usually mid to end project, last third. So a very useful tool for optimizing, especially in Unity, is the profiler. This will give you a detailed frame-by-frame report of basically everything that is happening inside your processors, your CPU, your GPU, all of it. It tells you in a lot of detail. It'll give you frame rates, how frequently a function is being called per frame, how much time each function is taking, the percentage of how much of your processing it's taking up compared to other things. And overall, it is a very useful tool, and this is how you will diagnose what needs to be optimized. Because usually you go through this, find what code is the worst in terms of time and performance, and then that's what you start optimizing. You don't just optimize all of it, it's what's the worst, because that's where you want to focus your time. Because if you have infinite time, you could optimize everything, but you got to remember when you have deadlines to meet, fix the worst problems first. So how do we access the profiler? I can actually show you right now. Here's some images, but in Unity, it is under Window, Analysis, and then I clicked the wrong spot there and clicked the scene instead. Profiler. I believe you can also Control 7. Yes, and that'll pop up. You won't see any information on there yet until you start running. But once you start running, it'll give you the full detailed layout and rundown of everything. Like actually, I can just hit play now, and you'll see it come to life. It gives you kind of this little chart here of everything that's happening. It's color-coded, although I don't like that some of the colors are very similar. I'm sure there's a way to fix that. But then if you click at any point, it'll automatically pause your game, and then you can move this bar to check what frame you're on. You can go left and right by one frame at a time to analyze everything, and it updates your layout down here. If you're looking for information from specific systems, you can turn off certain parts of this so that it only divulges some information, not other information. So this is just seeing garbage, which I'll talk about in a minute. Other things is you can rearrange this information based on the priority you want it to be displayed at. Like I have garbage collection at the top, but you can drag it to the bottom if you prefer, and that just changes where the priority it displays it. So let's not have that running in the background. So how do you read the profiler? Because there's a lot of information there to absorb all at once. So you'll see the chart that it creates is basically how much it's impacting your frame rate at that frame. So how many frames per second are you getting at that moment? The higher the spike is actually less frames. So those are the spots that you want to check what's happening. Is the higher the spike, you want to lower those. On the side in the bottom panel is where it'll actually tell you the hierarchy, which is basically every single function that is running in your project and what it's doing. So you can see here that in this example, there is a code called projectile that was running, and this is the update function of that projectile, and it can tell you what percentage of the total processing it took up for that frame, and then you can do drop downs to see what sub functions are being called and how much processing they took up as part of that. So you can actually get a full breakdown. You can see how many times it has been called that frame, how much garbage and memory was allocated for that function, and then the amount of time that that function took to run in the background. It's measured in milliseconds, and that's very, very fast. But you also might be slower than you actually expect. So I'm going to actually take a sip. So how do you actually optimize? First thing you do, look for your lag spikes. Where is the worst lag coming from? You can then check. You can check here at that. Let's say here, if I check this frame, I could then see which function was taking up the most time there, and that's how I'll know that that lag spike probably came from that function. You want to find, like I said, find the script that was in and start cleaning that up. Fairly simple sounding. So here's some simple things you can do to clean up your code. These are fairly easy ones. Most of these are probably self-explanatory, obvious, but might as well go over it. First of all, clean up dead code. That's just code that is running that doesn't actually need to. An example could be at some point you had an if statement that checks something, and then later the value that's being set that the if statement's checking stops changing because you've changed how your code works on the line. Now that if statement is useless, and it's taking up processing power by checking it. So just, yeah, clean up your dead code. One is only call the information where you need it. You'll see that example actually coming up a lot later on some of my examples, but basically the idea is if you need to access a piece of information, only actually access it where it's needed. So an example could be, let's say you wanted to say variable x is equal to 1, and then you had a for loop that did something, and then after the for loop it does something with x equals 1. You don't need to set x equals 1 in the for loop because it doesn't need to get reset to the same thing, every single time that loop iterates. Other things could be if you've got a score, which I actually have an example for later. Don't check the value of your score in the update if you don't have to. Only check it when that score changes. Same thing with like a health bar. Only check the value of your health when you need to check the value. There's some other uses for it, such as like position checks only check your position when you need to know what the position is, not every single frame or in other functions for some reason. Another one is another important thing is avoid update where possible. The update loop. Good day. The update loop can people overuse it. I've seen it overused a lot for things that it doesn't need to be used for, such as setting scores, like I said earlier, getting variable references, checking values that don't need to be checked every frame, and that will slow things down. Don't put don't put any loop in update if you don't have to. I don't know a reason you would have to, but just like those can seriously slow down your game as well. And frequently cache your frequently used variables. That's actually an example here of that. This is code that I have seen people use where they keep using get component on the exact same object over and over again instead of doing it once, caching that, and then checking the cached one. Because every single time you're getting component, the same component, your computer has to go through all the steps of finding that component again and again and again, when you could just store it in your memory once and you don't have to keep checking over and over and over. It also makes it so much more readable because the get component calls are very long. But this goes for other types of variables, though I know it's most often I've seen it with things like components. So most of what I'm going to be talking about, the more specific examples, are going to be about garbage, which is not what you take out of your house every Sunday. Garbage is basically just your storage that your computer allocates to do things. It's memory that your computer says this memory is going to be set aside to do something right now. In most languages, it is created by creating a new object. Every time you create or destroy an object, it has to allocate memory for that object. And what garbage collection is after that memory's been allocated, it eventually needs to be released back to your computer to be used again. And that releasing it is often where lag spikes can come from. C#, which is what Unity uses mostly, is very helpful in that it does a lot of memory management for you, such as automating the garbage collection process. But the problem with that is because you have less control over when and how it collects and releases garbage, it'll often just like make a big batch of garbage and release it all at once, and that will be a lag spike. The pipe dream is 0 bytes of garbage collection, an allocation at any point. That's not always going to be realistic, and not all of your game's lag problems can be solved by reducing garbage. In fact, mostly it'll reduce lag spikes and not constant performance, but lag spikes can be very annoying and oftentimes very easy to prevent. So how do you reduce your garbage? So avoid frequent string concatenation. So when you're adding 2 strings together or adding information to the end of a string, and this is because strings are actually secretly arrays. And every time you add strings together to concatenate them, it actually has to, in the back end, it is actually creating a new string and then adding the 2 strings together and then returning the new array, which that creating that new array there is actually causing garbage. Another one is avoid find object. That call, that also generates garbage because it actually has to search a list of things in the scene. So using that frequently will cause problems. I've got an example of each of these coming up. And reducing your instantiate and destroy calls and reusing objects actually come together, and I'll show you how later. That's my favorite example at the end. But every time you instantiate something, you are creating a new object, and every time you destroy, it also has to do stuff with the with garbage collection there. Other things that create objects is anytime you use the new keyword, so new vector, new array, new list, new wait for seconds in your coroutines, that is actually creating a new object which allocates garbage, which allocates memory, which creates garbage. Finding ways to cache that stuff beforehand is really good for preventing lag later. So let's talk about strings for a second. So yeah, compiler creates a new object, concatenate strings. So avoid concatenating strings in like update, for example. You might have a timer running in your game. That should be usually pretty fine. Actually, that'll almost certainly be fine. That won't cause enough lag. But let's say you've got a dozen systems that have UI, like your score, and then a health bar, and then your ammo counts, and then let's see, your mana inventory. If that's all being checked and updated in the update loop, that's going to cause some garbage. And I've actually got an example that you can actually see the garbage being made. That's what this scene is. So I've got in the code here, it's this one. Very simple. It just says the score is equal to the score plus score. So that's just saying that it will now concatenate those two and print out the score. It's being called an update. I've seen this in people's code before, usually new programmers, because they think, oh, it's just really easy. You know, every time the score gets updated, it'll do it automatically, so I don't need to think about it. But if we actually run this, see, the score is not updating because score only updates when something happens. But you will see in the profiler that there are 62 bytes of data being stored just from the string updating every frame, which isn't a lot on its own. But then, like I said, imagine having multiple things that need to update on your screen, because most games, don't have just one piece of UI. They've usually got more than one, especially something like a shooter or a adventure game. And one way I can show you that that can reduce that issue is the score in this is only going to change when I press the button, such as in a game where your score only changes when you kill an enemy. So if it only changes when one certain thing happens, or potentially multiple sources causing the same thing to happen, then only update it then. So what I'm going to do is take this out of the update loop, put it down here in the add score button, let Unity do all of its stuff. Now if I play, there is no bytes of garbage anywhere, except for when I press the button, and that happens for such a brief second that I don't even know. Oh, wait, there we go. There we go. Now I know it looks like a lot more, but that's, I believe, because of the button call. But yes, it only happens sometimes, and not every single frame, which is a lot better. Another way you can actually make strings more efficient is with String Builder. String Builder, the way it works is it's a class in Unity that basically does a lot of the same things that just concatenating strings does. Has a couple of other fun functions, but mainly for concatenating here, what it does is it actually allocates a bunch of storage when you start it for this, instead of allocating storage every single time. So if you've got to concatenate more than once, it'll just store all that data, allocate all that memory once, rather than allocating it every time you're concatenating afterwards. So you can see here with this this for each loop, let's say you've got a list of names or list of vectors or a list of items in your inventory, and you're going to print like 5 to 20 things at once. Instead of doing it concatenating every time, where in this case it will create a new array every single time, which is allocating more storage every single loop, you can just allocate basically a whole bunch at once, and then it'll work for it through it there. That way you're only getting garbage collected once instead of having to repeatedly do it. It's not worth it for most cases, but for something like looping through a list, it's usually not. It's usually worth it. So finding objects. So you want to usually avoid finding your objects using find object on runtime. If you can, simply you drag it into your objects manually as a variable, or find them on start or awake rather than in the middle of the gameplay. There are times where that's unavoidable, but usually you try not to find it on the gameplay. And I can show you that creating garbage in this scene. In this scene, I have set up a sphere. Well, actually, I've set up, I think, 1,000 spheres. Yeah, 1,000 spheres, all of them having a script I just call slow on them. And then the main object here will have the searching script, and all that searching script is going to do is every frame, it is going to create a list of every single object it finds of the type with the slow script. And this is going to create a lot of garbage. I'm going to add. So let's let that run for a second or two. And if I scroll through it, 24.5 kilobytes are being allocated for this. Now, granted, you're probably not going to be searching for 1,000 at a time, but this just shows you how bad it can be. Also, it took 24 milliseconds, which is actually a lot of time, all things considered, in your computer. And it's just every single frame. Instead of doing that, instead of finding it all like that, it's a similar thing you should be doing with things like get component. There we go, script. Instead of doing it in the update, do it once in your start or your awake, because usually the things you're searching for are probably things that are going to remain in scene or only need to be found once. And this will clear. Try to stop it before it goes too far. Yeah, you get a huge spike of garbage right at the beginning, and then look at that. Afterwards, there's nothing, absolutely nothing. And look how much. Look at the time on all that. 3, 4, 3. That is a huge difference. And that kind of stuff, that kind of jump, you will actually see like a frame drop from if you aren't careful. See. Sorry. So let's talk about instantiating things smartly now. In a similar vein to the find object, try to instantiate as much as you can at the beginning of the scene, like on awake or start, because while that will cause a slight amount of lag, your players are significantly less likely to notice lag in the first frame or few than they will notice the lag in the middle of the gameplay. If you're instantiating, 100 enemies in the middle of the gameplay or one at a time, that will cause lag as the game plays. But if you instantiate a bunch of enemies at once and then, let's say, deactivate them at the beginning and then only activate them as you need them, that will reduce random lag spikes in the middle of gameplay. I know it's really easy to just say instantiate in the middle of runtime, but like I said, that's asking for random lag spikes, especially in a game with a lot of enemies. If you're playing, let's say, a multiplayer game with bots in it, instantiating those bots in the middle of the gameplay can cause problems. Here we're going to talk about my main code example with my concept of reduce, reuse, recycle. We're going to talk about object pooling in a second. If you're going to be instantiating and destroying objects over and over, for example, you've got a game with weapons that are projectile-based, so actual physical objects being shot out of it, don't destroy those bullets. Reuse them. This can go for a lot of other things like pickups in your games, Enemies even, instead of destroying them when they die or when they impact or when they're picked up, deactivate it, hide it, and then just bring it back in somewhere else. Because turning an object off will not cause garbage, but instantiating and destroying it will. Which is where object pooling comes in. Object pooling is a very fun technique of basically creating a list of things that are not active and then pulling those things out of the list and setting a bunch of data on them so that they can be used again later. I use this a lot when making games with, like I said, projectile-based weapons, and it can significantly reduce garbage, actually by quite a bit. So let's go swimming. I will bring up my examples. I'm going through this a lot faster than I thought I would. So I'm just going to put that to the side. Object pooling. So in this scene, I will zoom in on the objects. I've got about, I think, 100 or so of these little cannons I've made. All the cannons do is every single, well, an update, they will instantiate and destroy a little sphere that they tell some data and will shoot it, and they just keep doing that. Think of it like Bloons Tower Defense, or just like I'm trying to think of another shooting game that has projectiles. Splatoon. Splatoon's projectile based, right? Yeah, yeah. So things like that. Enter the Gungeon, good example. Ones that actually have physical bullet projectiles. Ooh, Cuphead would probably be doing this too.
Yeah.
Those kinds of games, when you're actually making physical projectiles repeatedly that then impact things and do stuff, disappear, and then are used again later. This one I'm actually going to turn on the stats, because when the garbage collection spikes, you can actually see a frame rate drop. I think last time I was checking it, I got a 20 FPS drop every time garbage collection triggers. Yeah, so they're just shooting. And you'll notice these random drops. There you go, 50, 50. Yeah, it's not as extreme as I remember, but it does drop quite a bit sometimes. And if you check, you can see just using 20. Hard to find the exact spots. But you'll see that there's 23 kilobytes being stored up here, and that is causing performance drops. Let's see, find another one. Yeah, 14 milliseconds, 12 milliseconds. Just these big spikes. This one had 36 frames per second. That's pretty bad. But I will now show you what it looks like, and then I'll actually walk through it slowly how it works, so that you, anybody watching, can also make their own object pooling. So I've got what's called the object pool. I've made it a singleton, mostly for ease of access in this example. You might not always want it to be a singleton, but this just makes it really easy for me to access in the context of this example. So the way it works is it's actually going to instantiate a whole bunch of objects at the beginning of the scene in start, which is, like I said, do things in start where possible, because no one will notice the frame rate drop at the beginning, but they will in the middle. So what it does is it just spawns a bunch right away and then deactivates them, and it adds them to a list. The list is the pool. Some tutorials will have you make a active pool and an inactive pool. I've only ever used an inactive pool because I've never had a situation where I need to know which ones are active. Or at least with projectiles, I've never had a situation where I need to know which ones are currently active. I've only ever needed to know which ones aren't. But you might have a situation where you need to know where both are. And then the way it works is whenever it's called, it will return a game object, which in this case is the projectiles. So what it does is it simply checks the pool, finds one that is inactive, in the pool and takes it. If it finds nothing in the pool, which would mean the pool is currently empty, it will instantiate a new one. It's okay to instantiate a new one every once in a while, because, if you've got, let's say, 30 enemies on screen, and you've calculated that those 30 enemies will only ever be able to shoot 30 projectiles at a single time. But then later in development, you decide one more enemy, and now your calculation's off, and you have to recalculate. It's basically impossible to predict the exact number of projectiles or objects in the pool you will need, which is why you can pre-instantiate as much as possible, and then what it does is it adds a fallback where it just instantiates a new one just in case. And then this is how they get returned to the pool. It just deactivates the object. For this example, I have it set its velocity to 0 so that it doesn't build up speed every single time they get shot again, because they are physics-based. And then it just adds it back to the pool. I'll show you how that works in a sec, how it actually looks like in a second, but basically instead of the projectiles, you can see here, they have a lifetime. So they check how long they've been in the scene for. For you, in your project, however you decide to turn them off is up to you. For this example, lifetime is just pretty easy. I could have also done like on trigger or on collision, which is what most bullets would be doing, or both even. But in this case, instead of destroying, I'm going to instead add it back to the object pool using the return to object pool function, where it returns the parameter is itself. And then in the shooter, you'll see that update has a bit of a delay to it, so they're not just spawning a million at once. But the instead of shoot being a double checking that was a notification for me here. Okay, I'm good. Instead of instantiating, it's going to be a couple lines extra, but these couple lines extra, I'll go over them in a second, will help reduce the garbage collection, because in this case, it is simply getting a projectile from the pool, setting it to active, and then setting its stats, which in this case, the projectile stats is where it's starting at, which would be in this case, on the shooter, it is the gun's point. Then it gets the direction it's shooting in, and the amount of force it's shooting with. And the reason I set it up like this is that basically means that you can use the same bullet prefab for like 10 different types of guns. Like, let's say you've got one gun that shoots way faster, then it's just the gun that needs to check the speed, not the projectile itself. More examples of only calling information where you need it. But yeah, it just sets the direction and the force and where it starts from. That way, every single bullet is 100% reusable, which is better for the planet Earth. So let's see, shooter, make sure that's saved. Object pool, saved, and that's active. So I'll show you the performance difference now. So there we go. Quick spike at the beginning there. You can see a huge spike at the beginning. And I believe this spike would be when it's realizing that there's not enough space for objects yet, because it does need to instantiate a lot for the number that there are here. But as I run, I can now scroll through it, and you'll notice at most like 40 bytes instead of the second ago that there was 22 kilobytes, which is a whole magnitude of difference. Like, I think that's thousands of times difference. Yeah, 0 bytes, 0 bytes, 0 bytes, instead of 22 kilobytes. Very, very simple, very easy. I can now walk through the code step by step for implementing it. Oops, wrong tab. There we go. So the object pool, like I said, I made it singleton, so there's a static reference to it that's public. In the static reference, it just checks if this thing is not the reference, then it destroys itself. That way, you only ever have one in the scene at a time, and that makes it very easy to access. Now, this design philosophy here isn't always easy to maintain, so You might not always want it to be a singleton, but like I said, this is a small example. And then in start, it'll instantiate a number of them. I could theoretically change that number to like 1,000 or 2,000 or 3,000. That just changes how many you start with in the pool. But like I said, it'll be difficult to predict the exact number of projectiles you'll need depending on the project. So having what I showed before, the adding more, is useful. The most important two things, though, are grabbing things out of the pool and putting things back in the pool. So grabbing things out of the pool, all it needs to do is return a game object. So it caches a variable for that. Then it will check everything in the loop. Cool thing about for each loops right now, for each loops are often actually slightly more efficient now than a regular loop when searching for an array, which is only because it actually knows how many things are in it. It has to do with how it's compiled. Rather than having to figure out how many things are in the list, it knows how many things are in the list, which is nice. And then a quick null check just to make sure that the object does still exist, because things are weird and sometimes things stop existing, and that's always fun when that happens. So you just got to make sure that it's not null. And then if it's not null, then you found an inactive object that's in the pool and that can be used. It's that easy. So then you remove it from the pool, and you just get out of the loop, because there's no need to loop the rest of the data if you found a thing that you can use. The next step is to then check, did you find something? So what you're checking is it null? If it's null, then you did not find anything in the pool, and it is as easy as setting the returnable object to an instantiation of the prefab. That's as easy as that. You don't even need to add it to the pool in this context, because you will immediately be removing it from the pool anyway. And then you can just return the thing that you found, which will be, in this case, the bullet. And then returning an object, like I said, it is as simple as taking in the parameter of the object and putting it back in, setting it as inactive so that it's not rendering, not calculating, not doing anything, and then adding it back to the list. In this case, I also have it tell its rigid body to go velocity 0, although now that I'm thinking about it and I'm saying it, projectile probably could have done it itself here. Yeah, it could have. Actually, you know what? I will correct my own code right here. I'm not above that. I will do something slightly more efficient. It already has a reference. Oh, no, wait. I was supposed to do that. No, this was planned. This was planned. I just forgot my own plans. Don't worry. Yeah, this is what I was saying about storing your components from the beginning. Instead of every single time the bullet is deactivated calling the rigid body, store its rigid body right from the beginning. And then here you can just tell it, turn the rigid body off. See, it goes back to 3.0. Works exactly the same, but it only needs to find the component once. See, I know what I'm doing. I'm a professional. That's why I'm the lead programmer. You're right, Casey. You're so right about that. So yeah, that's object pooling. There's a lot of uses for it. Not every project will need it, and it will not, like I said, it will not fix your code's lag entirely. Like it won't be fully optimize your code with just object pooling. You need other techniques. Not any one of these can fix all your problems, but they can reduce the number of problems you have. And a lot of these are just good coding practices to think about anyway. So thank you for coming to my presentation. Thank you for coming to GPC. Are there any questions? Yes, Casey. Oh, thank you. Thank you.
Why do you not have the difference between dividing and multiplying numbers?
Ooh, I was going to do that one actually. Yeah. I remember multiplying and dividing are weird. Multiplying is, I believe, the expensive one, right?
It's dividing.
It's dividing. That's the expensive one. Instead,
Because dividing takes multiple clock cycles, whereas both of them, I believe, take multiple clock cycles, but dividing is significantly more.
Yeah, instead of dividing, you can actually just multiply by a decimal point instead.
Yeah.
That's basically the decimal fraction. And with multiplying, if you know you're only ever going to be multiplying something by 2 or 3, there's ways you can get around it, such as just like adding it to itself, because addition is not expensive at all. Like another like silly small one that I've seen no one do before, but actually can be helpful. If you're doing a for loop through an array for some reason, instead of doing it checking the count, you can store the count once and then check that variable, because otherwise it actually does have to go through and count the array every single loop of the for loop. Any other questions? Actually, I can open up the Discord, just read. Ooh, observer pattern.
That wasn't really a question. It was just
No, I'm gonna read that out. I'm gonna read that because that sounds interesting. Yeah, that basically using events. Yeah, those are cool. Haven't actually used any of that myself. But I also don't update UI that much personally in my projects. I haven't made much that needed it yet. Yeah, well, I mean, that just changes. That's because of the kinds of games I've made so far. Some games that stuff can be really helpful. Actually, I really like events. Events are great. Well, I'm not seeing any other questions popping up, but I have the room for another 13 minutes. Anything I cut from that I had cut for time that I'd like to go over? I don't remember what I had cut for time, because I didn't know how long this would take me to say things. Writing things always looks longer than it does actually take to say it. So I cut some things. What did I cut? I'm trying to remember. Some of these things I wrote at 2 a.m. and I shouldn't have. I remember. What was it? Ooh. Nobody online could agree on how Git component works. I found listings of people saying that Git component creates garbage because it creates a list of all components on an object to find the right one. Other people said it creates no garbage at all, and other people were saying that it only creates garbage in the editor because it creates a null object for debugging purposes. Which was very interesting to see 3 completely different answers to that question. So it's not really a helpful tip. That's more of a the internet's weird and finding answers on optimization can be hard. There are other techniques that I didn't get to cover, like threading. I did not think I would have enough time to adequately cover threading, especially because I would have to double check my understanding of it, because I know how it works conceptually, but I've never had to use it in practice, because I've never made a project where it's worth the effort of setting up. But threading is something that you can do to do some cool stuff. I was sent a cool video actually by some GPC execs for like being able to render 1 million objects at once using threading, which is impressive. So you can do some cool stuff with that.
some other things. Oh, someone else is talking.
No, go ahead.
Some other things to consider is cache optimizations, but that's also a little bit more fun to profile.
Ooh.
It's one of the reasons why for each is also faster than for, because it works better with cache and automatically pushing info.
One thing I almost forgot to mention too is with the profiler, you can actually get slightly more info out of it. I'll talk about this with the deep profile. It just basically just goes a couple steps deeper into your code. And like a trick to getting better info of the profiler is using separate functions. So like if you're doing things in the update loop, make a function for this instead, and then you can check in the profiler. If you do that, it'll actually tell you which functions in update are causing more things. Because in this current situation, it would just say updates the problem. But if you broke these up into functions, it'll then tell you which functions are the problem in update, which is nice.
I mean, yeah, I guess the other thing for profiling, if you actually want to get like deep profiling, you want to be using your IDE, unless you need graphical stuff.
Yes.
Then you would either want to go with, depending on what you're trying to profile, that's either like RenderDoc or, you know, your engine's profiler.
Yes. Yes. There's a lot more data here in the profiler. Most of it didn't matter to these examples and would take a while to go through all of them. Physics is going to be one, depending on your project, that might take up a lot. Rendering often takes up quite a bit. But for the sake of this, I was going to talk about just CPU usage because that's the easiest one to cover.